Thanks. Hello and good morning, everyone. So you're welcome to this last session on functional programming of this pre-sessional course. And this functional programming in C++ is one of the important as well as state-of-the-art concept, particularly inspired or motivated by lambda expressions or lambda functions in mathematical logic that was developed earlier by Alonzo Church in 1930. Well, so let's start with this one. So first, first we'll see what are the lambda functions basically. So it is basically a concise and anonymous function. So it doesn't have any name. That's a very kind of strange kind of things, and that functions are defined directly within your code. So suppose you have a lengthy C++ code, and you would like to write some kind of computational code there, and that will give you some kind of special, let's say some kind of special concept you're going to implement in your code, and these lambda functions are some functions that will give you a very cleaner style of coding. Okay, so in this code will be very smaller, and you have to focus what you are going to do, not on how, because how will be done on behalf of you by the compiler itself of the G++. It was introduced in C++ 11 long back, say I think a decade ago, and to enable more functional paradigm, more functional program paradigms. Okay, and they are really useful for tasks like sorting, filtering, and callbacks. And I hope you are already familiar with some concepts like STL or standard template library of C++, right? So if you are really familiar with that, then these functions will be very, very much useful for you to use those STL based functions of C++ very in a very efficient manner. Okay, so why lambda calculus? So this is basically a formal system in mathematical logic, as I told you earlier, that this is practically inspired by some mathematical logic developed by A. Church in 1930, and also useful for computer science. And this is basically a foundation of the functional programming languages. So so there is a question that if C++ is object-oriented or a functional programming language. C++ is basically the mixture of both, right? So it's a kind of hybrid kind of language. So in case of object-oriented language, you will see if you are going to open a code, you will see there will be a certain set of classes. But in case of C++, while you are going to see a certain set of classes, additionally you will see at least one function that should be there outside the class, and which is your main function, right? And that main function is the heart of the entire stuff. So from where your code will be started its execution. Right, and it also, however, this lambda calculus also provides a theoretical basis for understanding of the anonymous function. So I am repeating the term called anonymous function because this function will not have any name. So that looks like some kind of strange concept, but this is the concept here, and that's the beauty of this particular logic. Okay, so now let's take a delve inside a deep dive on the key concept in lambda calculus. So functions as a first-class citizen in this particular concept. So where functions can be treated as a value, we can actually pass the function as a value to through another function. Okay, suppose you are going to call some particular thing, so you can actually suppose you are going to call some particular function, you can actually use the you can actually pass it by value, or you can actually pass it by reference. So similarly, while you are calling, you can actually use this function as this lambda function as an argument. So how we can actually do this? So I'll give you give a set of examples for this one, and also you can actually return from some functions. Okay, so they can be actually generating some value, and those will be the return value of a particular function. Okay, so we'll see all these things in details shortly. And this is very, very much functional, very, very much fundamental to the functional programming. Okay, so the second concept is called as anonymous function because these functions doesn't have any name, and these functions are defined without being given a name. Okay, so your function doesn't have any name, so how we can actually identify them? So that's the principal concept. So principal question so that we need to ask, and we'll see that how we can actually do that. Well, then it basically allows more concise and expressive code. So as I told you earlier, your code will be a bit more cleaner, so you don't need to write long class and functions and lots of stuffs. So rather you can just do some one-liner kind of stuffs, and you can actually come up with your idea. Okay, and this is basically some high-order functions. So functions that take other functions as arguments or return functions as results, and they enable some kind of powerful abstractions and code reuse. So your things will be, as I mentioned earlier, you need to focus on what, not on how. So from that point of view, you are going to implement lots of abstraction, and abstraction is one of the most important concept in the object-oriented programming paradigm, right? So as you have already seen that. So lambda functions in C++ are inspired by lambda calculus, as I mentioned earlier. And C++ lambda functions are basically anonymous functions, as they don't have any name, just like in lambda calculus, and they enable a more functional programming style in C++. Okay, so your code will be a bit more shorter, as I mentioned, and also simplify in simple words. They are not actually the full implementation of the lambda calculus. So lambda calculus is a big concept, or one of the most important concept in logical mathematics. So from that point of view, we can see that these functions are actually inspired by that, but not the actual or the proper implementation of the same thing. And they are basically constrained by the type system of the C++. So type system basically is talking about some kind of data types. So as you know that the int, float, those are the fundamental data types that are basically supported by the C++ compilers. And so these lambda functions are also bounded by or abstracted by this particular data type system of the C++. Okay, and they don't support the full power or the high order functions and function composition found in purely functional language. Suppose to implement something, you need to write a big function. So lambda calculus is not for writing a big function. Rather, it will be something that will give you a very small or short or clean code that can actually powerful enough that is actually powerful enough to give you very nice kind of implementation of a very small concept. Okay, so we'll see this in a particular example. Okay, so this is the example. So where you can see, so starting with the header file. So first you are going to load 3 different header files, starting of the IO stream, then you have vector, and then algorithm. And I think you are basically familiar with these header file systems. And then you are going to start the main function. So this is the main function where you first define some variables, and in this case just one variable called vector. Called numbers. So in numbers actually is a vector of 5 integer elements, 5, 2, 9, 1, and 7. We are going to sort a vector using a lambda function. So towards that, all we need to do is that std sort, then numbers.begin and numbers.end. So this sort is basically a function that is already defined in C++ STL or standard template library, which you have invoked through this algorithm, by inclusion this header file called algorithm. Okay, within algorithm we have numerous functions like sort. Okay, sort, find if, and you have also some lot more important algorithms are there implemented in C++ STL or standard template library. And now you are going to implement this sort, and sort could be actually overwritten or could be actually mentioned by using some kind of logic that will give you that what are you going to sort. So you can actually sort through ascending order, you can actually sort in descending order, right? So in this case, this will be the ascending order sort. So where your data will be in increasing order. Okay, sorry. So what we are going to do when you are calling the sort function, so numbers.begin and number.end, and these two basically implies you are starting from your starting element of the number vector of the numbers vector, so that is 5, and end actually implies the 7. 7 is the last digit or the end of your numbers vector. Okay, so you're starting from 5 to 7. Now you're going to sort them. How are you going to sort them? In some ascending order, and that particular stuff or that particular intention is basically mentioned within this particular part. That is starting from you have actually square brackets at the beginning, then you have int a, int b, and then you have return a less than b. Inside the sort, you just specify from where to start, from where to end, then which operation you are going to do. That is a sorting operation that has been implemented starting from these square brackets going till end of this curly bracket. Okay, so what then how is it basically interpreting? So basically, when your compiler will see this thing, that is square bracket starts, and you are doing this kind of some operations you have mentioned here as a function body, that will actually compiler's job to create an entire sort program which will sort the elements of this particular vector, where you have mentioned the elements are basically mentioned from by invoking .begin and .end function. Okay, so this is the job of the this code is really quite smaller in terms of while you are using these lambda functions, but if you're going to implement the entire sorting algorithm, your code will be a bit more lengthier, right? So this is the main benefit of these lambda functions. Well, so we'll see that what does this square bracket means, then what does this square does this int a int b, and what is this function body means basically. So we'll see all these things in detail soon. Right hand side, so once your sorting is over, then you're going to print the results in some sorted order. Okay, so that's how it basically works. So what you have written? So on the top, I have defined. So I have mentioned what we have written as a lambda function. So starting with the square bracket, then you have int a int b, then you have written a less than b. So entire things basically implies some sort of code that is actually generated by the compiler shown below. So when compiler sees this particular code on the top, it will generate something like that. So that is class, then some generated class name. So some class needs to be implemented to implement this particular sorting algorithm or sorting function. So then you should have some constructor function. So constructor doesn't have any body in this case while you are defining it. Then you have some bool operator. So bool operator is basically, operator is also another function that is being implemented in inside the standard template library of the C++, and that can actually take int a and int b, then it can actually generate return a less than b. So this is basically a boolean function. If a less than b, and that takes actually two integers here, a and b. If a less than b, it will basically return 1. That is, yes, a less than b, so I am returning 1. These things will be implemented there. And once this part is basically implemented by the compiler, your code shown in the previous slide will be actually populated with this part. That is, this part will be replaced by the code I have just now shown you in the next slide. So this part will be basically populated with the code that compiler has generated. Now, this code will be executed and it will be generating the particular sorted vector. So how does it happen? We'll now delve inside the more details of this one. So before delving inside the more about the code, so we'll have some motivational part. That is, we have heard about the functions, we have heard about the objects. So how about the function object? So function object is one of the most important concepts here. Probably you have seen in your last lecture, and we have the foundation for that is basically construct the foundation for functional programming in C++. So basically, a programming paradigm where the building block of computation is the application of functions to arguments. Then you have the functional programs that specify a data flow to describe what computation should proceed instead of how. So how basically implies when you are writing some kind of some sort of code, source code. So here the most important part is the data flow, right? So you should actually make sure that you are maintaining the total store order or write serializability to maintain the functional correctness of your entire code. Now that basically actually talks about how you should proceed, okay? But in this particular case, as I mentioned you earlier, that functional programs that they specify a data flow to describe what computation should proceed. So here you have to consider only what part, not the how part, okay? So how will be done on behalf of your compiler, but provided you have mentioned some particular logic or some particular style of coding. An algebraic programming style that dominated by function application and function composition. C++ doesn't enforce, of course, the functional programming, but it allows to write code in a functional style. So that's why C++ is one of the hybrid languages that we have currently in the market. So C++ is not purely functional programming, or not it is purely object-oriented code programming style. Okay, so next you just come over here, that's a function object. So function object is any object for which function call operator is defined, and you have the CPP ref for that, and we have function objects combine properties of the function and object, so can be called like functions. And you can also call you can actually use these function objects by passing them as an argument to other function store state like objects, okay? And for function pointers, functors and lambda expressions are the function objects. So these are basically the function objects, okay? So you'll see more details example of this thing. So basically in one line, function object, so functor are basically the object of a class that overloads the function call operator. So operator is basically a function that is already defined in the standard template library. And you can see the functor example here. So on the left hand side, we have a class called increment by. So we have this increment by is basically our constructor function here, so which doesn't have anything in its function body. So we have defined that at the beginning. Then we have the void operator. So this function has been overloaded here. So operator is not operator is already defined somewhere else, and you have other plus equals to inc underscore, that implies other equals to other plus inc underscore, and you have one private data member, that is inc underscore. Okay, so this is how you have written it. Now while you are going to use the functor, so what are you going to do? You are simply writing the increment by function. You are just calling that increment by within this for each function. Okay, so for each is another function, so that is also defined within the standard template library of the C++, and we have first defined that there are 3 elements in this array. So let me show you. So probably it's so you can see that there are 3 elements, 1, 2, and 3, and these 3 elements we are now going to increment them. So by 7. So we are incrementing them by 7. So when you are calling this for each, then you are starting with the array.begin, array.end. So that is the first element to last element. So entire array is given. So within this stipulated range, you are now going to pick up each and every element, and you are increment them by 7. For that, what are you going to do? You just simply call this increment by 7. So you are passing this function as an argument of the function called for each. So for each will have now 3 different arguments. So starting with array.begin, array.end, and you have the increment by 7. So you can see that while I am adding as an argument, the third argument, increment by 7, is basically a function through which you are also passing some value. So that's the beauty of this particular code. So you don't need to write the entire thing or calling a special function for that. You don't need to do that. So just increment it by 7, and automatically for each will basically do the job on your behalf. So it is basically the job of the compiler. So compiler will implement the entire code. So you don't need to write the whole code here. Okay, that's a very nice fashion style of coding in C++. Okay. So next we need to take a look at the lambda function details. So just come here in lambda expression. So construct a closure, so an unnamed function object capable of capturing variables in scope, and it's a concise way to create a simple function object. So can be seen as syntactic sugar for the functors. Okay, so that's a very important statement. So syntactic sugar basically says that your job to write code for the functors will be reduced when you are going to implement the lambda expression, and that's the very good that constructs the foundation for functional programming in C++. And use of lambda for anonymous or nameless functions comes from the lambda calculus, which is a theory of functions, and that was developed by Alonzo Church in 1930s. Okay, these are very whole formal systems on reasoning about computation using lambda calculus. And here is the lambda expression. So lambda expressions are basically the anonymous function objects, and syntax is basically started with the some square brackets, as we have seen earlier. So but I have not yet discussed anything about the about this style or the details of this particular style. So first there are 3 parts. So first you have the within square brackets you have something called as capture clause or captures, and then you have the parameters, so the arguments you are passing through a particular lambda function, and finally you have the function body or the definition of the function. Okay, so captures basically, or capture clauses basically define the outside variable that are accessible from within the lambda function body. So within this body you are going to use some kind of variables that has defined outside or declared outside the body of this particular function. So starting from here to here you have the body of the entire part, so you have the entire lambda function. Now you are going by this capture clause you are going to capture some of the variables from defined earlier outside the scope of this particular function. That is basically ensured by the compiler. So compiler will basically fetch some value and throw inside the body of this particular function. So and that you need to mention the same thing within the capture clause. Now capture clause can be given two types of permission. So one is for read permission, another is called as write permission. So when you are capturing, by default it will basically give you the read permission, because you are asking for some variable that is outside the scope of your entire definition. So it's logically always good to give you some permission called as read permission, not the write, because write means you're going to modify the value. So write permission will not be given. In case you want to get some write permission, you need to use some, you need to capture them by reference by using ampersand. Otherwise, you can default all the variables captured by copy by using equals to sign. And by default, if you are going to mention any particular variable defined earlier, is absolutely fine. But if you are going to, suppose you have some variable called d, so d has been defined earlier. Now you are going to declare earlier, and you are just putting d instead of equals to. That means that the d can be used within this particular function, lambda function. But if you are using ampersand d, then only you are going to get the write permission. So why do we have this kind of issue? Because when you are going to capture some particular variable, that implies compiler basically create an additional copy of that particular variable defined earlier outside the scope of the lambda function. Suppose, as I mentioned, d was earlier, so d was declared earlier. So once you have d declared earlier, so when you are captured it by copy, that means that the d will have multiple copies created within that particular lambda functions. Okay. Now, if one copy within a particular lambda function is basically defined, then what will, if one particular copy of that particular variable is modified, then there should be a kind of memory inconsistency. To cope up with the situation, so the capture by reference has been introduced. So where you do not have the copy, but the same variable you have declared earlier will be used at the same location. So multiple copies will not be created here. So just single copy or single existence of a particular variable will be there, and that will be used by entire lambda function. So you can have multiple lambda functions within an entire code. So every time you are going to capture them by reference means the same copy will be used multiple times. Okay, so you do not have any kind of data inconsistency. Next, parameters. So parameters are basically the arguments. So that acts as input to the function. So those will be the input to the functions. And then you have the body, so that the function or the work you are going to do, you can simply write inside the body. So body are usually, in case of lambda functions, body are really small piece of code, not the huge code. Okay. So that small piece of code is basically give you some kind of coding efficiency for the users. Okay. So we'll see some examples soon. So basically in function scope, suppose a equals to 2 given on the top. So that's the first one is basically an example of an empty lambda function object. So you do not have anything declared. So capture clause at the beginning is empty. Then you have no arguments and you do not have any body. So this function will do nothing. But this will not throw even some kind of error as well. Next we have the second part. So here also you don't have any argument and any kind of capture clause, but you have some body. It's called lambda definition. So it should print this one, and then you have, when you are going to execute this code, this will also give you some kind of printing statement there. Okay, but at the end you can see we have additional brackets here. So what does it mean? So we'll see this a bit more later. Now, you are going to invoke some kind of lambda function here. So right, so these are the definition of the lambda functions. Now I'm going to call lambda 1, and when you are going to call some lambda 1, so here also you have another one more type of definitions where you are starting with this one equals to sign, and when you have make this equals to means it will basically capture all variables declared earlier. In this case, just we have a, and a has a value of 2. So a is here now, and as I mentioned, this is actually call by value. So we cannot actually modify a within this particular function body, and we are just here reading it, and we are just printing the value of a here. Okay, that is called actually capture by value. Now you are going to execute this one, this my lambda 1. You can actually use it like this. So this is a function, you are now executing this. So this entire thing will be executed here. So that is basically a will be printed along with the next line character. Now you have auto my lambda 2. So this is another style of coding. So where we are basically capturing a with ampersand. That implies we are basically we can actually have the write permission now. So we have actually assigned 4 to this, and now we are going to print a here. So you can see the value of a has been changed, and you can actually return 5 after that. Okay, well, so lambda 2 will be assigned the value of 5, where a will be assigned to the value of 4. Now you are just going, when you're going to call this my lambda 2. So my lambda 2 has been called here, and finally you have the std out. So my lambda 2 and next line. So you can actually write 5. You can actually print 5 and execute it. Okay. So you can actually check this particular link, that Godbolt. So where you can find a lot of examples. Now we have the lambda expression. So that's the definition of function that is only required locally. So everything you are defining within the lambda function is basically local. It's not global. It doesn't have the global scope or something like that. And then what you have is the implementing a higher order function, that is functions that take functions as argument or return function, that we have already seen that the function can be used as an argument, right? And as input to functions in algorithm library or SYCL. So those are the very well-known some predefined algorithms in C++. You can find all of them in standard template library of the C++, and as a manner to store functions for later execution. So now let's take a look at the this example. So where you can start with the array called ARR, where you have three different variables. Now I am going to show you some kind of lambda expression here. So std for each, array begin, array end. So you are starting from 1, you are coming up to end, and for each is basically some kind of standard template library based function. So and you are doing some operation on this particular. So here earlier we have seen that we have used some kind of functor called increment by. So where we are going to increase the each and every element by 7. Now also we have the another scope. We have this lambda function to do the same operation. You can see that our code is much more cleaner here. You don't need to write or implement the entire class as well as the constructor as well as some other functions. So here what you are doing for each and every element, simply write this one. So you don't need to capture anything because we don't have predefined variables earlier here. Okay. Now what we are doing, so these operations will be performed on particularly on this. So this is for each function. You start with the begin, coming till end. Now there are some operations that you have mentioned that will be done upon this upon all the elements within this particular range, that is 1, 2, and 3. What we are doing, so if your argument is I, that is each and every element 1, 2, and 3, each and every time it will come here because this is basically a for loop, and then each and every element will be incremented by 7 in this particular case. Okay, so this is how it will work. So you are going to get the value or assign the value within the ARR as 8, 9, and 10. And earlier this code was like this. So earlier code was like this. So you can see that this is the implementation of the functor. So you are incrementing it by some particular variable. So in this case this was 7. So we have just called it increment by 7 earlier, and this time it's defined already with 1. So that's the default assignment. But when you are going to use this particular lambda function, you don't need to write the entire code. Okay. So that is basically a simplistic version of this entire code shown on the left. Now we'll take a look at the advanced topics called lambda expression. So after finishing the lecture, we'll see several examples on lambda expression and lambda calculus. Okay, so that's the generic lambda expression. So introduce the concept of autoparameters in lambda expressions, enabling them to deduce argument types at compile time. And we are going to highlight the increased flexibility and code reusability offered by the generic lambda expressions. So first one is auto add. As I mentioned to you earlier, so all kind of data types, that is data types or the keywords that is actually defined in C++ template or C++ library. So our lambda functions are basically bounded by that, and it is actually obliged to use all those kind of data types. Okay, so auto is one of them, and auto add. So it implies that any kind of data type you can use here, and auto A and auto B. So then finally you are going to add this auto A and auto B together, and sum will be basically returned from this particular lambda function. Now what you're doing is you can use the same thing here. So you can use int, you can use double, but you don't need to specify any kind of parameters here no need to do any kind of typecasting. Okay, so I think all of you are familiar with the typecasting. That is, suppose you have defined some variable as integer, you would like to use it as a floating point or double, you need to do the typecasting. Okay, so you need to change the variable types before using it. Okay, so from that point of view, so if as you are using auto here, auto keyword is some keyword that actually automatically converts this or does this kind of typecasting on behalf of you. Okay, you don't need to write the entire code. Okay, So while you are doing int sum int, so then you are add 5 3. So add 5 and 3 is basically this function, and add is basically this one. Add is basically assigned with this entire lambda function. So when you are doing this add, so add is basically perform. Add will basically perform this a plus b operation. That is 5 plus 3 will be added, and sum will be printed. Finally, you have the double, the same one, so the double sum doubles. Again, you are going to use the add function here, but this time you have 2.7 and 1.3, and you can actually use the same thing here as well. Next, we're going to explain that lambda expressions are translated into compiler-generated function called function objects called functors within the overloaded operator, and briefly discuss the concept of closure, capturing variables from surrounding scope. So let's take a look at the scope a little bit more. So you have the int factor equals to 3. That is one variable we have declared, assign value 3 into it. Then we have the auto multiply by factor. So we are going to multiply some number by this factor. So factor is basically 3 here. So when you are using like this, so capture clause basically captures factor. So factor is defined earlier, as I told you, that if you have declared some variable earlier or used it earlier, you can actually capture it by capture clause. So you have used the factor. So factor is not called here or not declared within this capture clause with this ampersand sign. So we don't have the write privilege, but we do have the read privilege. So what we are going to do, so when you have this argument num ready, so num will be multiplied with factor as a result, and which will be returned from here, okay? So and will be assigned to multiply by factor. So now when you are going to call this multiply by factor function by 5, so what will happen, the result will be 15. Why? Because 5 is basically the num and 3 is basically the factor. So 5 multiplied by 3, so finally you are going to get the product, that is 5 cross 3 is 15. Okay, and this is how it should work. Now if you would like to change the content of the factor, that you need some write privilege, you need some write permission or write privilege, then you just need to put an ampersand beginning of the at the beginning of the factor. Then you can actually change the factor, and whatever you want you can just do there within this particular function body. Okay, so explained by default that lambda expressions capture variables by value, making them read-only within the lambda's body, as I mentioned earlier, because without mentioning the ampersand, we'll make it completely write protected, and you have the introduce the next thing is that we can actually introduce some kind of keyword called mutable. So mutable is basically a keyword which is used mostly in case of the lambda functions or lambda or lambda expressions. So where you can see we have introduced counter, so declare it here at the beginning of the code. Then you have the auto increment counter, so we are going to increment the counter. Now when you are going to do some increment operation, you are basically changing the value or modifying the value of this particular location, right? So as I mentioned earlier, if you are capturing it without ampersand, you do not have the right permission. But when you are using the mutable keyword, so this keyword will make it basically enable that you can actually have the right privilege. So while you are doing this counter plus plus, this will never throw you an error during compilation, and this can actually be helpful when you are going to write some value to a particular variable. So mutable is another way of doing this, and then you have the increment counter. So once you are going to call this increment counter, so counter will now be 1 because initial value was 0, so and 1. Once you have done the counter plus plus, it should be 1, and this is possible because you are using mutable keyword. So we'll see all these things in our detailed example later. Let's take a look at the immediately invoked lambda expressions, so which is called actually IILE. So immediately you can invoke some kind of lambda functions. Okay, so directly you can call. You don't need to call it. So earlier what we have done. So this is our lambda expression. So starting from the square bracket, end of this closing curly bracket, right? So this is your entire lambda function which you are going to assign to this result. So earlier what we have done, we have called result with this number of arguments. So number of arguments are 2. We can call result by, let's say, 5 3 or 3 5, 1 2, 3 4, whatever you want. You can just call them. Now when you're going, you know the value that is 3 and 5. Some immediate value could be actually written here. So these are the specific numbers you have just written here. That's why it's called actually immediate. So once you have executed this particular part, the result 15 will be automatically assigned to this particular result. So whatever you want, you just do there. Just simply change the values here, and you can get the result easily. Okay, so this is how it should basically work. So after finishing after closing the entire lambda statement, that is before the semicolon, but after defining this entire lambda function or lambda expression, you can write you can actually mention your arguments within a particular bracket, and thus the result will be printed here or assigned to this particular particular variable called result. Let's emphasize the synergy between these lambda expressions and STL algorithms in enabling concise and expressive code. So suppose you have a vector called numbers, like earlier 52917. These are the 5 elements of this particular vector. Next, we are going to sort them. So in this and in this case, we are going to sort them in descending order. That is, if it should return 1, so when a greater than b. Okay. So we are going to see that the 7 will be the first element, then 9 will be the first element, then 7, then 5, then 2, then 1. So you are going in some decreasing order. Now, this is the code. So this is the lambda expression that will make sure that yes, you are going to sort the elements in some descending order. So as we have mentioned in this lambda expressions. Now we are actually finding out the first even number within this entire array. So what are you going to do? You can actually use this find if algorithm. So find if function is basically defined. This algorithm is actually defined within your standard template library. And there you can just call this function and you just start with the numbers begin, numbers end, that is the entire vector or entire array. Then you can actually use this lambda expression starting from this to this, and this will give you some results. That is when you are getting the first even number, it will actually return the value of this. Okay, so let's say we have the 52917. So first and only even number here is 2. So this will actually find 2 and it will print it. Okay, sorry, it will basically assign it to IT. So in summary, we have that compact anonymous function for on-the-fly use, which is basically a lambda expression, and this is the syntax. So first we have the captures or capture clauses, then you have the parameters. So parameters means number of arguments as much as you want, so you can just write it there, and then you have the function body that is the primary operation that you are going to do. Then captures are basically the control access to external variables. You have some benefits. So functional styles. So it actually can offer you the functional styles in C++. Your code will be a bit more clear, clean, concise and expressive, and it's really ideal for sorting, filtering and callbacks, whether these all are basically the powerful algorithms implemented in the standard template library of the C++. So just take a look at this particular code. So we have started with the iostream, then vector, then algorithms. There are 3 different header files. So in this particular example, so we started with the main. So main is basically the only functions that we need to execute here that consider the main body, and we have first a vector defined called numbers, and where we have 5 different elements in this particular vector called numbers. That is 1, 5, 3, 2, and 6. And using a lambda function, we're now going to double each of the elements here of the vector. Okay. So starting with that, so we have the std for each. So standard template library has offered one function that is called for each, and that will be that has some kind of type signature. That is, it will take the first element to last element. That is the range of the entire vector, entire number set of numbers. In this case, the numbers dot begin, number dot end, and we need to do some operations, and in this case that has been defined by some lambda expression or lambda function here. And in this particular lambda function, you can see we don't need to capture anything, so we are just putting the capture clause empty. Then we have the one parameter. We have one parameter that is int ampersand num. So we have taken this parameter by passing its reference, that is ampersand num, the address of this particular element, and then we are going to multiply it by 2. Okay, so that is, we are going to double it. That's a very simple thing here, and then we are going to print the modified vector. Then because the value will be stored within the same location, that's why we called it through some reference. Okay, so now for int num numbers, so you have this particular thing, that is, we are going to print the all elements of this particular vector by putting a particular space, and then we have one end-line character, that is std : cout, then std : endl means that you are going to the next line of this one. Okay, so let's compile it. So if I do the compilation here, so what will happen? So if I can do simple g++ lambda basic.cpp, and that will generate a.out. So a.out is basically the default output of any compilation, and if you are going to execute a.out, so it will show you the result like 2, 10, 6, 4, 12. So we have actually 1, 5, 3, 2, and 6 in our function. So let's check. So what we had there, so we had actually 1, 5, 3, 2, 6. So it should be 2, 10, 6, 4, and 12. Let's check 2, 10, 6, 4, and 12. So we have the same thing here, right? So this is the a.out. Now, instead of doing it, because we have multiple C++ programs here, so we need to actually create specific object file or specific executable file for individual program. That's why we can actually, we do not need that a.out. I don't want to generate a.out for all of them, right? So I will be confused. So while compiling, so I need to put G++, specify the compiler, that is a statement comment for compilation, and this is your input file, that is lambda basic.cpp. Then you just put -o, that's another option. So for creating object file, now you need to specify the object name, okay? Lambda underscore, then basic. I am giving the same name with the file without any extension. So let's compiler create something. So compiler has now create lambda basic, okay? So I can actually now execute lambda underscore basic, and I will get the same result here, right? So 2, 10, 6, 4, and 12. You can see that the a.out and lambda.basic gives us the same result. Now, if I compile any other program, let's say G++, then I can do, let's say IILE, okay, .cpp. Now you can check the result of a.out. It will be different. See, result equals to 8. So it's typing result colon 8. That is, a.out is default default name of the object file that C++ compiler creates. Okay. So it's always a good practice to specify your object file for your specific object for your specific program. Okay. Okay. Let's delete a.out here now to avoid any confusion. So I don't have the a.out here. I don't want to keep it here. Let's take a look at the lambda basic once again. So lambda basic still prints 2, 10, 6, 4, 12. So that's how it should work. Well, so we have seen the lambda basic. Next we are going to take a look at the generic lambda expression. Okay, so let's open vim generic lambda expression .cpp. So this is your generic lambda expression example. So you can see once again we have the 3 different header files starting from IOStream. We have the vector, we have the algorithm, and once again we have defined the same vector here 1, 5, 3, 2, and 6, and name is also same, it's numbers. And then what we are doing, we are going to print the element here. That's called actually generic lambda function to print any type. So auto print element. Then we have the const auto element. So captcha clause is practically vacant here. We don't have anything in captcha clause. Then in the argument list we just have element alone, and then we have the one print statement that will print the element of that particular of that particular variable. Okay. So content of that particular variable will be printed here. Next we are going to use the generic lambda with std for each. So for each is basically the function that I have told you is defined within the algorithm header files in our standard template library of the C++. So C++ compiler can automatically invoke that function and can and make the entire code for you. Now, so within this particular for each call, so what we are doing, so we are calling for each, then we have the numbers.begin. So this is number.begin. So this is the first, this is the range that you would like to do, and in this case you have the 1 and you have the 6. So numbers.begin and numbers.end, and finally you have the print element. So print element is something that is basically printing all the elements, and as print element is basically our this lambda function. So auto print element. So any types of element could be printed by using this particular lambda function. So you're basically printing the value here. Okay, so you can even use it with other types. Let's see, we can actually use it with a string. So there are hello world. So there are 2 different words within this string. So it's called words. Words is the name of this particular variable, this particular vector, and the type of the type of this type of the elements are type of the elements is basically the string in this case, which is also defined in C++ compiler. And then we have for each function. Just call the for each function and start with the words.begin, that is the first element. You have the words.end, that is the last element, and then you have the print element. Okay, so print element is basically the same thing that we have done here. So to showcase that how basically this lambda functions implements uses the defined data types, especially with the auto keyword. So auto keyword means is connected to take the any kind of data type, is a primary objective in this case. So that we are going to show that how auto is basically used by these lambda functions. Okay. So then we are going to print this next line function. So next we are going to do this end line. End line is basically printing one extra line for you to make the code much more readable. So let's run this code. So this is basically our generic lambda expression. So let us compile G++. generic lambda expression dot cpp. Then I am creating a new object code for this generic lambda expression, and then let's compile it. So compilation is successful, we don't have any error. Now we're going to do the execution of this one. So generic lambda expression, you can see the result is basically first it prints the value of the vector, that is the integer vector, the 1, 5, 3, 2 and 6, and then we have the hello world. Hello world will be printed, right? So by using auto variable, you can see that the auto keyword, you can see that the two kinds of things we can actually do. One is the integer, next one is the string. If you have any double or any kind of other data types that are also supported here. Okay, right, so let's take an example. Take another example, let's say with the lambda STL. lambda STL.cpp. So here once again we have the 3 different header files. I'm not going to give you the details of that now because we have seen it already. Then we have the number. So there are 8 different numbers: 3, 1, 4, 1, 5, 9, 2, 6. Okay. So find the first even number. So we are going to find out the first even number here, and this will be printed. So you have to take the entire range of the array. So starting from the begin till end, you have the end function here, and then we have this lambda expression here. That is, we don't need to capture anything, so we just keep the capture clause vacant. And then we have the num. Num is the number, and then you have the that's what is basically the argument we are passing through this lambda expression. And then we have the return num modulo 2. That is actually for the for implementing the logic of the even number, right? So once you have the even number, it should actually print it. Okay. So now if and we are assigning the entire thing into it. It is another variable which is kind of auto type. Okay, its data type is auto. So whatever you have, it could be actually stored in it, right? So if it not equals to numbers.end, so that is, you have already you have not yet exhausted the entire vector, so you can actually print the first even number. So just print the first number, that is star it, and then you have the std cout no even numbers found. So you don't have any numbers. You don't have any numbers that is actually even. Okay. So let's execute the same. Quit, and then we have the G++. Then you can actually have lambda STL, and here we need to change the value, change the name, G++. Then you have the lambda STL, you have CPP. Let's compile. So we don't have any compilation error, so we need to actually execute lambda STL. So first even number is 4. So let's take a look at the code once again to see if first even number is 4 or not. Yes, we started with 3, then 1, then 4. 4 is the first even number, so that's what is printed. Okay. If I let's do it by changing the value. So I am just changing the value of 4 to, let's say, 7, and sorry, it should be 7, and then you have the 2 here, or I can change 2 to actually let's say 5 once again. So let's take a look. So it should print 6 now. Let's compile and then execute. Is 6 correct? Then if we don't have any kind of suppose we don't have any even number here, so we can actually test it with 7, let's say. Then just quitting. Let's compile it once again, and then let's run. So no even numbers found. Okay, so in both ways it looks good. Well, then we have next code. Let's say let me just take a look what else we have. So we have seen the lambda basic, we have seen generic lambda, and then we have done lambda STL. Then we can take a look at the mutable lambda. Okay, so vim mutable lambda dot cpp. Just opening it. So here we haven't used any kind of standard template library function from the algorithm header file, so we don't have that. That's why just iostream is there. So we don't have the algorithm header files. We haven't included that. And within the main function, first we have defined one variable. So we declared x with the by assigning 5 into it, so as a default value or the initialization. Then we have the auto increment x. So increment x will basically increment a particular value. Okay. So what do? We are capturing x here. Okay, if you are going to capture x, then what will happen? So you can actually have the right, you can actually have the privilege of using x within this particular lambda function. But you are not assigning any kind of ampersand, so that implies you cannot actually write the value. To overcome this problem, so we have actually done the mutable. We have actually used the mutable keyword here, and as you have used the mutable keyword here, so it will not create multiple copy of x. Rather, it will actually use the same x, and it will actually give you the right privilege. So you have the privilege of incrementing x here. So you are now going to modify the value of x at the same location. So same variable will be incremented now. So we have assigned 5 initially. So after one time calling this increment x function, that is a lambda function, you have your value should be 6. And while doing this operation, you can see the value of x will only be incremented after calling this, not within this one. Okay, so outside, so within the scope, the value of, while you are calling x, so x at this particular location, x is always 5. Okay, as long as you are within the function, the value of x will never be changed. Once you're calling this one, so outside you can see the value of x will be changed. So let's take a look at the output. Okay, so let's compile it first. G++, you have the mutable lambda dot CPP minus O, you have the mutable lambda. Next, let's run mutable lambda. So let's see. So inside, so outside is 6, outside is 5, but inside it's 6. So within that scope only it will be written, but when you are outside, coming outside the scope, it will never be changed. So sorry, I did the reverse. Okay, so inside the lambda, your value will be always be incremented because you are doing the operations here, but when you are outside the scope of this lambda function, it will never be incremented. Okay, so as soon as you will call this, your value will be 5 will be changed to 6 here, and when you are outside, so it will be remain same as you declared here, 5. Okay, well, so next we have the last one, that is the IILE dot CPP. So here you have the main function. So start with the here also we haven't used any kind of standard template library function, so we don't invoke anything. So we just include the IO stream here, that is a standard input and output. And here you have the int result, where you can actually see a b and return a plus b, and then 5. This is the immediately invoked function, so that's why we called 5,3 here itself. And you can see that we're doing some addition operation, that is 5 plus 3 will be added, and your result will be printed. Okay, so that is a plus b is here. So when you're using 5 and 3, so 5 plus 3, so your result will be 8, and that should be assigned to result, and you are now going to print the value of the result. Okay, so let's quit, and if I do the G++ here, CPP, then you have minus O IILE. Okay, so you have now created the compiled file without any compilation error, so you can have this one. So let's see. Yes, the result is 8. So let's change some value here. So if I do this one, let's do the operation. So we change the operation, that is, we're now, let's say, doing it a multiplied, whatever, a multiplied b, and it should print now 15. So let's compile it once again. Compilation is done, so result is 15. So similarly you can try with something like this. Let's say we're going to change the value, let's say 15, and we have, let's say, 10, so it should print 150 now. Okay, okay, so that's how it should work. So this is your immediately invoked lambda expression, IILE. Well, so this is the entire concept of the functional programming. So I have given you one link while presenting the lecture. So just go to that link. You can find some more documents, and you can actually practice some exercises from there as well. And we're now going to stop.